The last time I visited my DYN Compu Lite clock radio was in 2013. And this thing's been running constantly since then, but the LEDs have gotten quite dim. It needs them to be done again. And a viewer asked me to provide him with voltages for the transformer because he's trying to fix his. And then I found out, well, the radio's not working anyway, so we're going to give this thing another look, get the radio working, and replace the lights again. Let's check out this rare beast. So today's video, I'm going to feature this DYN clock that I've had for many years. This is the mechanical digital clock that I've had. Now, in the prior video, we upgraded the lights. This is an electromechanical display. As you can see, when you dial the numbers, it actually I'm gonna have to service this thing again. This knob is not working properly, but it actually moves shutters. But what's happened is I upgraded this to LEDs years and years ago, and the LEDs have not lasted. They've failed. So, viewer wanted to know what the output voltage of the transformer was. He has one with a defective transformer. So we're going to open it up, measure the transformer voltage, and I'm going to try and get some different LEDs in there that might make it look a little bit better because it's looking a little bit dim. So first we'll open the unit up. On the bottom there are a couple screws. We'll see why the LEDs aren't working properly. This was going to be a really short video, but looking at the footage I've shot and how long it took me to figure out what the problem with the radio was, it's a little bit more in-depth. Come off this thing, take out two screws, and then the back should lift up and off like that. So we'll disconnect the speaker like we did before. Oh, some of the LEDs look like they've failed, actually. Interesting. Yeah, it's a strip of LEDs, but either they failed or they're just not very bright. I mean, they're actually pretty darn dim. That's interesting. Let me just get the speaker disconnected. Turn on the soldering iron, and we'll disconnect the speaker, and then we can measure some stuff in here. But yeah, that LED strip has become exceptionally dim. Should have been a lot brighter than that. Fortunately, I have better LEDs now, so maybe we can make this work a little better. As you can see, I actually put two strips of LEDs in here. I just hot glued them in. No, did I hot glue them or zap strap? I think I zap strapped one of them in place, and the other one I hot glued. But yeah, the LEDs themselves are really quite dim. Hot glue. That's how I put those ones in. I got two strips of them in here, and they're both dim. They're both really quite dim, as you can see. Now, this might just be the nature of these type of LEDs. They may not have been high brightness ones, but I got ones now that are certainly a lot brighter than this that we can certainly put on here. If I can get this hot glue out of here. There's one, and I'll cut that zap tie that I put in place to hold the other one in. Or zip tie, or whatever you want to call it. Zap strap, zip tie, same thing. And here's the other. You see how dim these are? I think those LEDs should be a little bit brighter. Now I might be under voltaging them too, but I think they should be. They should look brighter than that. But let's just see what voltage I'm giving them. Obviously they're getting AC instead of DC, which will affect their brightness. But they still look to be. They look to be pretty dim. Well, they are running on 13 volts AC. So I would think that they should be considerably brighter than that. Let's check out this strip of LEDs, giving them the same power. Yeah, no comparison. No comparison. These ones are shot. So much for LEDs lasting forever. They certainly don't. These are the ones that are actually rated for outdoor use, like weatherproof. They got a plastic coating over them, but yeah, they're crap. Okay, the guy that wanted to know what the voltage of the transformer is, they're in luck. Let's just measure the voltage between the two black wires. So from one black wire to the other, that's 6 volts. 6 volts between the two black windings, and there's a red winding on here too. So there's two windings. There's a black winding, which is 6 volts. The blue is the primary. So there's two windings, 2 separate windings, and the way they've got it wired, they've got them both going to this switch here. Looks like. So there's it's 4.5 volts across that one, and the white wire here, where does it go? It goes down here. It's connecting to the other red wire. So the one red wire here is connected to this white wire. So between the white and the red, if I look at the white here, which is, again, this is the other side of the red wire, we have, looks like 9 volts. I see what I've done here. I've put them in series with each other to get the voltage up. We've got 8 volts. What's my input? Make sure my input's actually set for 120. I don't know whether my variac is set to 120 or... Oh, I'm only at 116. Let's just put the power up. Okay. Now I'm at 120. So the red winding, one winding, I see how I've done this. I've wired them so that they're in series with each other to get me the voltage for the LED. So the one winding is a 9 volt winding right there, right? And the other winding is a 5 volt winding. So between the two, that will give me 13.6. But the two windings are in series. It's how it's wound. This is a dual transformer. So you need a transformer with a 9 volt winding and a 5 volt winding or a 6 volt winding is what this has on it. And if I remember correctly, because to say I rewired this, the lamps themselves were around the 6 volt. They had incandescent bulbs, so that was on the 6 volt winding and the radio was on the 9 volt winding. That's how it's wound. That is what I remember. Now, I want to see if I can fix this time set knob. It's kind of broken on the front here, so see if we can fix that up. I'm just going to unplug it, and we'll change out these lights. Get something a little bit brighter in there. So I want to take the clock out. I don't know the exact year that this was made. I've had it since about 1970 or 71. And I picked it up when I was young. I was probably only about 9 years old when I got this, 9 or 10 years old. A little less, maybe 8 or 9 when I got this thing. It was the second radio I ever had. The first one was a flip. And I got this at a garage sale when I was for probably 25 cents when I was a kid. And I've had it ever since. I find it's just so cool. Now, if this unit was stock, it would have 2 incandescent bulbs stuck on here, sticking out either side, 2 to light up the hours and 1 to light up the minutes, 1 to light up the hours. But as I say, the bulbs burned out years and years and years and years and years ago. And I got tired of replacing them because incandescent bulbs just don't last forever, right? They do burn out, and when I replaced them last, I put LEDs in. But as we can see, the LEDs really didn't last as long as I hoped. Pop off the knobs. That one comes off. This one should come off fairly easily, I hope. There we go. Now let's just see if I can get this. Now this is a very rare unit. I've never seen one again. In fact, this is the only one I've ever seen. I mean, I'm sure they were out there, but I guess I got to take this. There's another rare one that is a mechanical clock that used neon bulbs to form the segments and used plastic drums that activated little switches. I had one of those as well, and it broke and it got thrown out, and I'm kicking myself. I should have kept it because it was really cool too. But this, I'll show you when I get this working. I'll show you the mechanism and operation. But it's basically a mechanical clock motor that operates these drums in behind the numbers, which have a cam that moves the lever back and forth, which opens and closes shutters to block or pass the light through the segments. I'm wondering what this bracket is for. It's just a metal bracket. I'm thinking it's to stop any magnetic flux from the clock motor from being picked up and amplified. I think it's just acting as a bit of shielding. I could be wrong, but that's what I think is there. Okay, there's the clock in all its glory, and the knob that's acting up is this one here. I just want to open this thing up and see whether I can fix this knob that sets the time. Oh, I see what's wrong here. It's broken. It's broken. There should be there is a little piece in the middle here that has come off. It's broken off from here. If you can see, this shaft is broken. So what I'm going to try and do is I'm going to try and glue this. I think I did that before. It broke again, but I'm going to try and re-glue this piece. I found a piece of a screw which is about the same size and diameter as this broken peg, and I've just drilled a small hole in the plastic here. I'm going to try and thread this screw in. And see if that will work. I don't know if it's too long, or let's just see how long it is right now. Whether it's too long, I think it's probably too long at this point. I got to shorten it a bit. So we'll just remove it, and I'll just trim it down a little bit. All fun and games until somebody loses an eye. Pieces of metal flying through the shop here. Okay, let's see whether this will allow this down far enough to turn. Still a little too high, I think. So we'll take a little more off. But we might be on the right idea here. If I can trim this down enough that I can make it work. And provide a little bit better long-term solution than trying to glue plastic that does not adhere very well to any type of glue that I've tried. I've tried crazy glue and I've tried epoxy, and neither one of them seem to hold this thing worth anything. So maybe, just maybe I can get it to work with a metal piece. Okay, almost. Okay, I've got that gear on there now. Let's just try putting this back together again and see whether it will mesh properly. Note that the colored glass determines the digit color, so I would imagine that this was probably available in different colors. You could probably get it in red or yellow or green or blue. I've only seen it in blue, but it stands to reason because they were illuminated with incandescent bulbs that you could get any color, or there were multiple colors of this module available to the manufacturers when they made them. Okay, let's just see if I can adjust the time. That's what it's all about, is can I adjust the hours, or can I adjust the tens of minutes and the minutes. So throw the light behind there so I can see it lighting up. And if I pull, I can adjust the minutes, and if I push, I can, cool. There, that ought to do it, I hope. As long as it can pull and adjust one and push and adjust the other, looks like that might hold it. So let's try to reassemble the unit now, and we'll deal with the lights. So we'll just swing the mechanism back into place. The knob's back on. That's off. One of these is for the alarm set, and one of them is for the radio power. That's that one. Off, on, and then you can set your time for it to go off. And then this one's for the wake up, on and off. And then there's one more knob for the it's a smaller, that's keyed for the alarm set. Okay, that gets that back together. Now we'll deal with the lights. This is the speaker wires here. Where's the other one? There's the other one there. Okay, now the lights. Let's do some brighter lights. As it sits, if I plug this thing in, we'll make sure everything's working. If you guys don't remember how this works, I've got a close-up of the mechanism down here. Get some light in there so you can see how it's working. But basically, there's a mechanical clock, a little motor here, synchronous motor, which is equivalent to the second hand. You can see that gear turning. You see the mechanism turning? It's turning that cam. And if we watch this, I'll get a shot of this. We'll throw some light in there. Let you guys watch what's happening. You see this lever is moving back and forth. It is so cool. And it takes 1 minute. And basically what it does is it will, this is turning like the second hand. So every 60 seconds, this cam that's right in there, you can see the crank on it. You can see the brass cam. So as it turns around, a little crankshaft there on the gear, it moves this mechanism back and forth. And every time it does, it's going to move this cam gear, which is going to move this lever. And this lever here is going to move shutters back and forth, which allow light through or block light from the backlights. So you can see the, there it is there. See, it's moving that cam gear. And there it is. And that is how this thing displays the time. It's one of the coolest electric clocks that I think I've ever seen. And that's why I just have to get this thing working and get some better lights in it so that we can see it in its beauty, because I want this thing to be the centerpiece of the room. And I don't care about the radio. The radio is just a bonus, just a transistor radio, but it's more the clock mechanism that's fascinating on this unit, just how it operates. If I go through the setting procedure here by turning the knob, by pulling the knob out, I'll do it so you guys can see it. So as I pull it, I can adjust one at a time. You see, I'm turning the cam, and this is moving the gotta wait for it, because you can only do it when it's not changing. Okay, so this changes the minute, and every time it slides this back and forth, this is just moving this cam, or the cam is moving this lever, and the lever is opening and closing shutters depending on its position. There's a mask here which has got slots cut in it, and depending on where it is will either allow light through or block the light. If I push, it will then adjust the tens of minutes, which is this one here, and it also, the tens of minutes, as you saw there, just moves the hour. So that'll be 1, 2, 3, 4, 5, and then when I go to the next one, this other one will turn. You see, and that's the hour minute. That's the hour that turned there. So the clock mechanism works. Let's get some better lights in this thing to showcase this unit. And I'm thinking a strip of these other LEDs in behind here probably will work better than these piddly little pieces of crap. So we'll remove the old ones. Zoom the camera out a bit. It's the white and the black wire here that I've jigged up to give me 12 volts, because let's say the original one was only running on like 5 volts for the old lights. I'm going to put 2 of these together, 2 strips. That'll give me enough light to light the entire display up and make this thing really glow. Polarity is not going to matter because I'm just giving it AC. The LEDs will strobe, but that doesn't really matter. You're not going to really notice it when looking at the clock. You shouldn't notice it anyway. Now I could put a bridge rectifier on here, a capacitor, and give it DC, and it would eliminate the flicker. But as I say, the flicker I don't think is really that noticeable on this. And the LEDs will work just fine on AC because they only pass the current in one direction anyway. So power. Oh yes, nice and bright. Now if I stick this in here, behind here, like this, or from this way, probably easier from this side. If I can stick this in here and get this to stick in the back here, like that, it should make this display nice and bright. Watch it nod. Yeah, it's not bad. Not bad at all. So I'm probably going to attach it again using a zap tie just to this little support. Remove the support so I can attach the actual lights to it first. And put the lamp holder back in place and adjust the LEDs accordingly. And just adjust the lights so that they're kind of facing towards the display. Now, see how this thing looks. There, that's pretty cool. Let's set it. 722, huh? If I pull this, I can go to 2. Push it in. You only turn it one direction too. 722. Cool. I'll just prop this up a bit so it shows off a little better on the camera at the angle the camera is, and we'll watch it change to 723, and then I'm going to reconnect the speaker. But yeah, these displays actually are pretty cool looking. And it's bright enough now that I can see it. There we go. See? I love it. Simplistic. And then you can see the time here to set the alarm. So I turn on the control here. I don't have the speaker on, but it turns a little dot on up in the corner here, right? For when you turn on the wake up. I know this knob is still a little bit loose because the screw that I used to mount it on is not quite the same diameter as the original plastic, but it's close enough. At least it holds the control in position so that it can operate and set the time, whereas before, when it was broken, it fell right out and it wouldn't mesh, so you couldn't set the time. You're going to put that shield back in place. So this is just a magnetic shield to stop the motor, because this is radiating out magnetism. If I put something in there that's metal, you can feel it. I'll demagnetize my screwdriver if I stick that in there. We'll just get the lights repositioned again where we want them so that they give us relatively uniform lighting. Time to reattach the speaker. Hey, look, it's a Pioneer speaker. I probably mentioned that the last time I had this thing apart, which was many years ago. I forget the last time I worked on this, but it was a long time ago. I mean, those LEDs actually did run for a while because this thing's never turned off, right? This thing's left plugged in 24 hours a day. Radio just goes back together just like that. Put the screws in it and I'm all done. Let's see if the radio is working. Where are we on here? Why do I not have any sound? I don't hear anything from the radio. What the heck? What else is wrong with this thing now? When I move the tone control switch, I don't hear any sound. I guess we have to fix the radio now too. Okay, Mr. Oscilloscope connected to the audio stage. I have audio. So we know it's in the amplifier. We'll go to the scope up here. So it's now off the station again. But I did have audio there. There we go. We have audio. And if I change the station, where are we here? I really like my CRT scope. I was going to do this with the digital scope and it just looks like crap. So much easier with a CRT. We have audio. If I go to the volume output, on the volume control, we have audio. So the problem is the amplifier. We're not getting any output to the speaker. If you notice, when I adjust the tone switch, you'll hear it clicking. So something's working. There's sound at the tone switch, but there's nothing getting through from the volume control to the amplifier. So I'm clipped onto the volume control now. I've got it set for a buzzer, and as you can see, as I turn the volume up and down, I get the 60 hertz, which is normally sent to the speaker. go back to music. And there's the music that would be sent to the speaker. So audio is coming back down to the board right there. I can see it. That's on the volume control. And it could be one of these caps that's bad, or even a transistor, but I'm not getting any audio going out to the speaker. Could be one of these coupling caps that's gone bad. Or again, it could be a transistor that's also gone bad. I'm just looking at whether I get any audio. I see nothing there. Nothing there. I think the audio amplifier is probably these transistors. That's probably speaker comes down over here. Nothing there. Nothing. It actually has a little. It actually has a little schematic here, or not a schematic, but a parts location. DYN Electronics, Miami, Florida. It says made in Hong Kong. It's not made in China, made in Hong Kong. Maybe not. Nothing there. No, nothing there. And I thought this was going to be easy. I didn't really plan on having to fix the radio when I started on this today. I figured it would just be a simple one to show the clock and measure some voltages and replace those dead lights. Now this has gotten a little bit more involved. I'll pull the radio out and see if I can spot anything on here. Go through it with the scope and see where the signal is being lost. I should be able to lift the whole radio out without affecting anything else. Just the couple screws that hold the radio in. Should be a screw down here and then one on the other side as well. And the whole chassis should lift out. I don't know how much clearance I'm going to have with the wires, but we'll see. Okay, there's the radio. I want to clean these switches to start with. These switches are pretty bad. They're stiff and they make lots of noise, and since the audio signal has to pass through this one at least, that could certainly create some problems. So we'll just spray some cleaner into the switches. Lots of audio there. I got audio down here. If you notice my watch is counting down, that's because I'm told that dinner will be ready, and that's how long I've got to work. I got 5 minutes to work on this thing, and then I got to break and go for dinner. So I better hurry up. Nothing in here. With everybody else using their smartphones for timers, but I use my old watch. In fact, I don't use my smartphone for much of anything, just email and talking, and that's about it. Of course, this was built long before they started silkscreening the boards, so it makes finding things quite difficult. audio's right there. Where does that go from there? Now I'm thinking at this point that it's probably a bypass cap. The audio right there. The audio is going to go into a small capacitor to be coupled into the amplifier stage. And then there'll typically be another cap from that amplifier stage to the next one. So I'm thinking maybe one, maybe two capacitors are bad. And that's what I'm going to look into changing. I'm looking at the caps to see which one has audio on it. Looks like it's probably that one. We're going to change out a couple and see if it fixes it. Coupling capacitor here. See it there. Audio's there. I'm going to try changing out one or two of these little caps that's right next to where the audio goes in. I think we got one that may be open. Probably more than one that's open, but I'm just going to try and get this in one shot. I just don't know which one it is. Try this, maybe this little blue one here. I can see where the audio comes in on here. I just don't know where it is on the side of the board because it's hard to see. It's hard to see where it is, but there might be this one here. Let's just see whether this is one that moves, or is it the one next to it. When you work on electronics, it's good to be coordinated with both hands. So I can solder holding the iron in either my right or my left hand equally well. Because you never know what you're going to be faced with when you're working on a board. I can write equally well with my left hand as well, by the way. That blue one. This is the input to the amplifier. I think this blue one might be the problem. What size is this, first of all? 10 volt. What's the small one? 0.5 microfarad. That is a real small one. We'll try putting a 0.47 in place of it. I don't know if this is going to fix it or not, but this is definitely on the audio path. So if that cap were to go open, we'd have no signal through it. Oh, I got sound. I got sound. So that one was bad. I'm sure there's probably a few others that are bad on here too that are limiting the volume here. I'm speaking loud, so try this other little 0.5 as well. Over here, this other little coupling cap, this other little blue one. See if that'll bring the volume up anymore. That's one. So I'm putting a second 0.47 in. I think I'm only going to do the two of them to get any little bit more volume out of this thing. Because I don't use this as a radio. Tell you the truth, I could, but I don't. I just use it to display the time. And I could change all the caps on here, but these boards are not that easy to work on. Just the way they're laid out, they're just an absolute mess. They were hand soldered. There's no silk screening. You kind of try to figure out where you are by heating up a connection and wiggling the parts and to see where you are. They're not really service friendly, if you know what I'm getting at. So let's just see whether, when I turn this on, whether I get any more volume this time.
For his life. If we can't get a conviction here,
yeah, we have lots of volume. Yeah, we're good. That's going good and loud now. Okay, so that's it. That's all I'm doing. I'm gonna just leave it at that. These two caps were bad, and we're gonna leave it at. I'm gonna put this thing together. I don't want to do any more work on it because I don't want to do any more damage to it. It's so old that you don't want to do any more than you absolutely have to on something that's this age, just because just moving things around could break wires and stuff, right? So get this light out of the way. It's great because it lets me see what I'm doing, but unfortunately it blocks the view for you guys at times. But it's more important that I see what I'm doing than what the camera can see. There it is. It's all done. Seems at the right time on it. 9:11. We'll let it change here. There you go, 9:12. Pretty cool. Thanks for watching, guys. We'll catch you in the next one. Bye.